Okay guys, let's get started. Uh, Today we are going to continue uh, the last title or the last topic that we haven't explained till now. It was about the loops actually. So let's get started. Okay, this is a folder for the examples for the loops. We have explained that there are four basic statements to consider when you are learning any new programming language. Okay, output instruction, input instruction, loop instruction, and conditional instruction. Okay, when we come to the loop instruction in C++, we have three types of instructions, or three instructions for this purpose. Actually, the first one is called while.
Share screen.
Yes, that's it. I'm so sorry, I forgot to share my screen. Okay, now we are talking. We have three instructions to do loop in C++. We have while loop, we have something else called do while, and we have for. Okay, these are the instructions for making a loop in C++. A loop is something like making an iterative behavior within your code. You would like to make some iterations to some piece of code, so you could achieve this by using one of these three instructions, actually: while, and do while, and for. Okay, let's take a look at our examples. The first one. Yes, that's it. It's very simple actually. This example prints the numbers from 0 to 10 in order. Actually, we have here our printf. It's our printf. We know about printf. Actually, printf prints what we are going to supply to printf. Here I'm going to supply something called counter. Counter is something like a value or a variable in C++, and is going to be printed on the screen inside a loop. Where is the loop? This is the loop. This is its start, and this is its end. Actually, when you are using while, the statement or the instruction while, you are going to write it like this. Actually, I'm going to copy this code and paste it here. So now I think it is more clear. Actually, let me enlarge my font. Just a second. Okay, it's bigger now. What do we have here? Actually, we have a while. When you are writing while loop or the statement while, it is going to be written like this. You are going to write while, then these two brackets, and these two kinds of brackets also in pair. Then you are going to write some code here. You are going to write some code here, actually, and between these two brackets you are going to write some kind of condition. Okay, some kind of condition. So when your condition is met, okay, when your condition is met, the loop ends. Actually, this loop is going to be ended. Actually, let's try our example. Here we have made a variable called counter, okay, and we assigned it to 0 initially, to be 0. Then we made a while loop, okay, and we set the condition that while or where you find this counter or this variable that's called counter is smaller than 11, then you are going to execute the code between these brackets in a loop. While this condition is met, you are going to execute what is going to be written here, okay. Actually, we wrote these two statements. The first one is printf the counter, the value of the counter, and the second one is incrementing this counter. We are going to write something like this variable counter is going to be equal to counter plus 1. So the new counter, the new value for the variable that's called counter, is going to be the old value for the same variable added to 1. Actually, let's run this code. Okay, it prints from 0 to 10 on the screen. Why this code prints from 0 to 10 on the screen? It happens because that we have written a condition that's counter is smaller than 11, okay, here. So while this condition is met, go on and execute the code here. What's the code here? Print the value of the counter, okay. So initially 0 is printed here. Actually, that 0 is printed here. I'm going to use something like bin or something. Yes, I think this could work for me. Yes, that's it. There is a problem, I think. Yes, it's here actually. Oh, thank you. Okay, so we have 0 here. There's a problem or something. Yes, that's it. So we have 0 here actually, okay. Then I think that it's not okay. Let's get back to it. Okay, we have 0 here actually. Okay, that's enough. We have 0 here actually. Then we have counter equals to counter plus 1, okay. So the new counter is going to be incremented by 1, okay. So now the new value for the counter is going to be 1. Then we are going back to our while here. The check is going to be that counter is smaller than 11. Yes, it is, because counter is equals to 1 actually. So 1 is smaller than 11. So the condition is met. So we are going here again to execute printf counter. So the new counter is 1, and going back, counter equals counter plus 1. The new counter is 2. So we are going here to check if counter is smaller than 11. Yes, it's smaller than 11. Actually 2 is smaller than 11. We are going to print the new counter, which is 2, and so on until we reach to the end. Okay, when we have a counter is equal to 10, then counter is incremented by 1, so it is 11 back to the condition. Okay, so 11 is not smaller than 11, so the execution is finished. Actually, this loop is finished now, and we are going to the end of our program. I think it's more clear actually. Okay. If someone have a question or something, go and raise your hand. Okay. Okay, that's it. Hello, Abdul Qawi. How are you? Okay, I think Abdul Qawi couldn't hear me. Okay.
I'm fine. Can you hear me?
Yes,
Good
yes,
evening.
I can hear you. Thank you. Welcome, Abdul Qawi.
Thank you very much. Thank you.
Welcome, Abdul Qawi.
Thank you very much for.
Okay, get back to our examples. The second example is for the statement do while. Actually, do while. Okay, we are going to take a look at it. Okay, copy and paste. Okay, it is pretty much the same. Okay, we have declared a variable called counter, which is initially 0. Okay, then we are going to use the do while loop, the do while instruction or statement loop. Okay, here it is written like this. We are going to write do, then our two brackets, then while at the end with two rounding brackets. Okay, with a semicolon at the end. That's the syntax for do while. Actually, you are going to write some code here. Okay, that's it. Okay, I'm sorry, I'm going to use this. Write some code here. Then you are going to write some condition here. Okay, and while this condition is met, okay, your code is going to be executed. But take care that do while always execute your code at least once. Okay, at least once before checking your condition. So the do while is different from the while loop, the original while loop. In this matter, it executes your code firstly before checking your condition. Okay, so let's get back. Okay, that's it. When we are going to run this code, pretty the same from 0 to 10 actually, and your counter is initially initially equals 0. Then you are going to do, okay, printf counter. So you are printing the value of the counter firstly, and then you are going to increment your counter value by 1. Then you are going to check if your new counter is smaller than 11 or not. While it is smaller than 11, so your code is going to be executed. That's it for do while. I think there are no questions. Okay. I'm going to repeat. The only difference between do while and while is that do while always execute your code, your iterative code, at least once. But while are not. While doesn't do this. I'm going to show you the difference here. Okay. If I'm going to write the two statements adjacent to each other, okay, like this. Take a look. While it checks about the counter here, actually, if your counter here is something like 20, and when you are going to execute while, the counter is by 20, so 20 is smaller than, it's not smaller than 11, so your code here, your iterative code is not going to be executed at all. But do while is going to execute your code at least once. Then it checks about your counter, it's 20, or actually here it's 21. 21 is not smaller than 11, so it's not going to be executed again. Okay, that's the difference here. Let's take a look at for loop actually. Okay, that's it for loop. Okay. Okay. When we are going to execute the code, it's also the same result. How it works actually. Here I have declared my variable which is called counter. Okay. Then I'm going to use this for loop. Actually, its syntax is small, has some small differences. Okay. You are going to write your code here. Okay. And here you are going to initialize your counting variable. That's it for now. And here you are going to write your condition. And here you are going to write something like incrementing or decrementing your decrement. I'm going to write this shortly. Increment or decrement your variable. Okay, that's it. So at this part you are going to initialize your counter or your counting variable. Here you are going to write a condition for your loop, okay, when this loop ends actually. And also here you are going to write the incrementing or decrementing phrase or statement that changes the value of your counting element or counting variable actually. That's the basic use of for loop actually. It can be used with more variations, but this is the basic one actually, and this is the way you are going to use it. Back to our example. Okay, that's it. Here I have declared my variable which is counter. I have initialized my variable to be 0. Then my variable now is going to be smaller than 11. That's my condition. After that I'm going to increment my counter with 1 here at this part. It's pretty the same. Okay, when we are going to run this code, okay, it gives us this result. It's the same result. Any questions here? I don't think that we have many questions for this session, for this whole session actually. Okay, that's it. So now we have finished this is all these three statements, basic statements or instructions for C++. Okay, Now we are going to the fourth one, the conditional statements actually. So now we are starting actually the content of the second session right now. Okay, let's get to this. Okay, the conditionals. Actually, we have two phrases or two statements. One is called if statement, and another one is called switch case. Okay, these are the two used conditional statements or conditional instructions in C++. Okay. Okay, let's go on and open. I think this could be 1, it's not 0. Okay, that's it. We are going to propose an example of a calculator program actually. This is a calculator program, a program of a simple calculator. Okay, let's get it here. Okay, actually the if condition or if conditional statement is going to be written like this. Here you are going to write if, okay, then you are going to write your condition here. Okay, after that you are going to write some code here to be executed if your condition is met. Okay, write some code here. Also, if has an extension which is called else, the else part. Okay, it's written like this. Also, you are going to write some code here at this else part. Okay, what is this about? Actually, when you are going to write some condition here, if this condition is met, your program is going to execute the code you have written here. If your condition is not met, your program is going to execute the code written here. Okay, so else part is the code that's going to be executed when your condition is not met. Okay, something like if you have $10, then you are going to buy a bar of chocolate. Else, you are not going to buy a bar of chocolate. That's it. It's a conditional statement. Okay. Let's see this statement in action. Actually. Okay, it's clear here. I'm going to run this program first. It's a kind of a calculator. You are going to input your first operand, your first value, and your second operand or second value, and your operator, the operator you want to be executed on these operands. Okay, and then your calculator is going to view the result for you, something like this. When I'm going, okay, to write something like 2 and 3 and the plus, so 2 plus 3 is going to be 5. The result is 5. Something like 7 4 minus, okay, so 7 minus 4 is going to be 3, and so on. 5 multiplication, 5 by 5 is going to be 25. Okay, So that's it. Let's take a look at our code. Actually, we have declared three variables here. One is called a, one is called b, and the last is called c. Is going to be e, sorry, is going to be a plus b. Okay, it's going to have the sum of a plus b. Okay, that's it. Okay, I'm sorry for the interruption. Just give me 1 minute. Okay, 1 minute, I'm going to be back. Okay, guys, I'm sorry for this interruption. Okay, back to our program. When your operator is plus, when your operator is plus, so the variable that's called c is going to be equal to a and b, the value and of a plus the value of the variable b. Okay, then I used my else part, and I have used another if after this else part. So I say else if, okay, my operator is going to be minus, then c is going to be a minus b, and else if my operator is going to be multiplication, for multiplication. Okay, so c is going to be a multiplied by b. Okay, actually I'm going to remove this for simplicity. After that, I'm going to check if my operator is going to be for division. Okay, so c is going to be a divided by b. Okay, so that's it. Actually, I think I have said something wrong. C is going to be a multiplied by b, a times b. Okay, and here c is going to be a divided by b. Okay, so that's it. And now I'm going to print the result. So I'm going to say the result is c, which is holds the result of the operation I have done to these two operators, sorry, these two operands a and b, and ruled by this variable which is called operator. Okay, so I'm going to run this program. I have entered 2. That's the variable that's going to be stored within a. Actually, I'm going to use this. Okay, 2 is going to be stored within a. Then I'm going to enter 3. So 3 is going to be stored within b. And now I'm going to enter my operator, which is for example plus. Okay, so this plus is going to be stored within C, and now I'm going to have my result, which is 5. Your program is going to be executed like this. If the operator is going to be equal to plus, yes, it's equal to plus, so the variable that's called C is going to hold the summation of A plus B, and that's it. Any questions here? I think it's very clear. Okay, Omar, go on.
There's something about the meeting itself. There was a notification says that 5 minutes so that the meeting will be ended. But I searched for that in the internet. And I knew that for guests is time limit. So if any guest would be out, can rejoin indeed.
Yes, yes, of course. Actually, I have searched about the time limit for this application, and till I have searched, which is from some little days, actually, small days from now. I have found that there are no limits on the time, but I think they have applied something like that recently. It's a recent update of Microsoft Teams, actually. So we are going to join back here at the same meeting, actually. Okay. Thank you, Omar. Thank you so much.
Welcome.
Okay. I think we are going to proceed with switch and case, actually. Okay, that's it. Switch and case. Okay. Okay, I'm going to explain it from the beginning. It's the same program, actually, but we are going to use switch and case. Switch and case is written like this. You are going to write switch, two rounding brackets. Then you are going to use these brackets or braces. Okay. Now we are going to use the second word, which is case. Okay. Okay. Case value some code here, break another value, also some code here, and there is a special case that's called default. Okay, I'm going to make this, yes, it's better now. The default case, also you are going to write some code here, then your break keyword, and that's it. I'm going to clarify something about switch. Here you are going to check about a certain variable, actually. So here you are going to check about a certain variable. You are going to check if this variable have a certain value. Okay, so switch works like this. Okay, switch check about this variable, in case you find this value, in case this variable is equal to this value, go and execute some code here, then go out by break, this break keyword. Okay, in case you find this specific another value, okay, go and execute this code here and go out. If you find no values mentioned here, there are no values that are mentioned here, none of these values is contained within this variable, so go and execute this code here actually and go out. That's the switch case keyword or switch case in a statement for conditional programming or conditional processing. Okay. Okay, welcome guys. Now in our example we are going to use it. Okay guys, if we are out of the meeting because of Google Teams, we are going to be back within the same link or within the same meeting actually. Okay. Okay, back to our case here. It's very simple and very straight. I'm going to check about this variable which is called operator. Okay, if in case this variable is equal to plus, you are going to execute this code. Please let the variable that's called C equal to the summation of A and B, A plus B. Also, if it is minus, please let it A minus B. Please, if it is times or multiplication, please let it equals to A times B. And also, if in case it is equals to this slash, actually, please make it C equals to A divided by B. Okay, and the default is nothing. Okay, try always to write the default case, even you are not going to write some code here, you are not going to write some code here, also write it. Okay, so you don't miss thinking about this case, actually the default case. Okay, and now the result is what is inside C. When we are going to execute it, it's the same behavior to okay guys, I'm going to wait for 5 minutes, sorry, for a couple of minutes for the others. I can tell that we are working on these problems with Microsoft Teams. Actually, they have updated their plans actually for the limitations on the application. Okay, let's continue our explanation. We are going to start our program. We are writing 2, then 3, then plus, okay. We getting 5, okay. Also, if we are going to try 7, 4, and minus, we are going to get 3, and so on. That's it. I think nobody needed to ask about something.
Share screen.
Yes, 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 of course. Okay, thank you, Omar. I forgot about it. Okay, back to our explanation. I'm so sorry. When you are going to run our program, 2 and 3 with plus is going to be 5. 7 and 4 with minus is going to be 3, and so on. Okay, that's it. Using if and the switch case. Okay. Okay. Let's get back. Now we are going to explain something about the variables. Okay. We have explained the conditionals. We are going to know something about the data types and the variables of C++. Okay. So I'm going to open this. I have some links for you. Okay. The first one. No, sorry, I'm sorry. Yes, that's it. Okay, that's it. I have a table here, very important table actually for you. Okay. C++ data types. This link is very useful actually. And I'm going to use a special table here, special table mentioned here. Guys, could you hear my voice clearly? I think there is a problem with my microphone here.
Yes, we can hear you.
Okay, thank you. Thank you. Okay, this table. These are the basic or the basic, yes, data types that are used to declare or define variables to be used within your program to store data. Okay. The first type here is called signed integer. Okay. Used for integers equivalent to integer. Okay. Its size in the memory is 4 bytes in bytes here. Okay. I think I'm going to enlarge this a little. Yes, that's better. 4 bytes in memory. A byte is something like a place in the memory to store data. A single byte consists of 8 bits. When you have, I would like to explain it here. Let's make a new file here. Okay. Okay, that's it. Okay. Take a look at this. Okay, that's it. 1 2 3 4 5 6 8. Okay, okay, we could make some numbering here. I'm sorry, it's better to make this start from 0. 4 3 2 1 and 0. Okay, this is called a byte. This is a byte in memory. A byte in memory. You could store some data here, which consists of 8 bits actually. These are the 8 bits you could store within. You could store something like, sorry, 0 1 1 0 0 0 1 1. This is the data. It doesn't actually it doesn't have a special meaning. I don't mean a special thing by this data, but you have stored some data within your program in this single byte actually. So you can store data here. When I'm going to say that I have declared a variable of the type integer or signed integer, okay, it occupies four of these actually in the memory. It occupies 4 of these, okay. So that's the meaning of a signed integer variable have 4 bytes in memory, okay. It's used for integers to represent integer variables actually, or integer values, okay. There is another kind of variables or data type. It's called unsigned integer. Also, it has 4 bytes in memory, okay, and it can only store positive integers. This can store negative and positive, okay. Also, there is something called short or signed short, okay. 2 bytes in memory. Unsigned short, 2 bytes in memory also. Long, 4 bytes in memory. Unsigned long, 4 bytes. Long 8 bytes. Unsigned long 8 bytes, okay. Long double, I wouldn't talk about this right now. Signed character and unsigned character, only 1 byte in memory, okay. That's the smallest one actually, okay. Let's get some examples here on these, okay. Now we have something like, we're going to start from here actually, okay. Signed character and unsigned character, okay. Let's define some kind of unsigned char a, okay. This is a variable, its name is a, and it's of the type unsigned character. There is something in C and C++ that's called size of, okay. Size of is an operator that could tell you what is the size of a specific variable. For example, here I'm going to see out size of a, I'm sorry, size of a with a new line actually, and that's it. Let's run. It's 1, okay. I'm going to write something here to clarify what I'm going to print. Size of a, sorry, equals, so we have here size of a equals 1. That's it. What if I have written signed character? Okay, it's the same also, the same size. It's going to be 1 actually. I'm going to tell you what's the difference between signed and unsigned, but for now the size is 1 because it's character. I could also remove this, okay, and run my program. It is the same also, it's 1, okay, and so on. Let it be unsigned. Let's try something else. Unsigned short b, okay, let it, okay, b and b. So size of b equals size of b, okay. Let's run our program, and you see b is of the type short, unsigned short, so it has only 2 bytes. I'm going to write something here to make it more clear actually. Bytes, I think it's better, okay, so it's better now, okay. 1 byte and 2 bytes, okay. When we are going to see what's going on with long, C, it's 4 bytes, okay. You see 4 bytes here. The next one is going to be long actually, long D and D, 8 bytes, okay. So now you are going to learn that, or when you are thinking about it, you learn that a variable has a space in the memory, okay. 1 byte or 2 bytes, 4 bytes, 8 bytes, and so on. So that's it, okay. Also, each variable now has its limits. What values should be assigned to it, okay. Here I have unsigned character, okay. I'm going to back here to explain about it. When I have a variable its size equals to 1 byte actually, that means it has 8 bits within. So if this variable is unsigned, it could be, or it could hold, okay, from 0 because it is unsigned, so it could hold the values from 0 to 2. Okay, I'm not going to answer this, okay. Could someone tell me what its upper limit actually? Here, what I'm going to write here. It could hold from 0 to what? What value? 8 bits, 1 byte.
0 to 7.
What?
8 bits from 0 to 7. from 0 to 2 power of 8.
Yes, that's it. 2 to the power of 8. And actually, it is better to write this as -1, okay? This comes from your Boolean algebra. If you have studied Boolean algebra, you would learn that if you have a variable that consists of 8 bits, okay, so the possibilities of the values to be contained within this variable could be from 0 to all ones, okay, all ones. All of these is going to be ones, okay. Actually here, in our case, all ones is going to be 2 to the power of 8, okay, 2 to the power of 8 minus 1, okay. The base is 2, the power is 8, 2 to the power of 8 is 2, 5, 6, minus 1 is going to be 2, 5, 5, and that's it. 255 from 0 to 255 could hold these values, all these values, not more than 255 and also not less than 0. It is unsigned actually. But what happens if this variable is going to be assigned variable, okay? It could hold from what to what? Could someone tell me the answer? From what to what?
We can say the half of 255, so it may be from minus 175 to positive 175.
170. No, it's not the answer. Actually, your answer is right. Your first part is right, but you said two wrong numbers. Actually, it's going to be from 2 to the power of 8. Okay. Okay, and these are
Minus.
yes, I know, but I'm going to write it the right way. Okay. 2, the same also. -1, and that's it. Okay. Here we are going to have 127, and here we are going to have, I'm sorry, this is 128, and here we are going to have 127. So that's it. Okay. What do you say, guy? Is it right? Do someone have a question or something? I don't think so. Okay. So this is how you could calculate and know what's your limits when you are using variables on a language like C++, and how you could calculate this. Also how you could know the size of a certain variable like this, size of something. Okay. I'd like to take another example. When it comes to 2 bytes, so now they are 16 bits. Okay, the variable is unsigned, it could hold from 0 to 2 to the power of 16 minus 1. Okay, we could use our calculator here. To the power 16 equals to this value. Actually, I'm going to copy this here and make it 5. Okay, also when I'm going to divide this by 2, so I'm going to have this value in minus to this value. So that's it. So now you are going to know that when you are using a variable that is 2 bytes, what your possible or your allowed values to store within. Okay, you are allowed to store from 0 to this value. Okay, and also you are allowed to store from this value to this value when it's signed. This limits when it is unsigned, and these limits, okay, when it is signed. I think it's more clearer. Okay, back to our table here. I think I have covered all of these, but I have one more thing. There are two more types actually I'd like to share with you. They are called float and double. Float E and double also. They are for floating point numbers. I think that B, C, D, E, F, so that's F. Let's get started. I'm sorry. What's wrong? So, I have made a mistake. They are not unsigned or signed. Yes, that's it. E, which is of type float, okay, is going to have 4 bytes, and F, which is of type double, is going to have 8 bytes. Okay, they are going to hold, both float and double variables are going to hold floating point numbers like this. Okay, when I'm going to print, let's do something like use this. All of these variables are integers. The character, the short, the long are integers. Okay, when I'm going to store a floating point data within here, and I'm going to D equals D and the same here for E, and the same here for F. Let's run it. Okay, that's it. You see, this variable D, when I have stored 2.4 within, when I print its value, it's going to be only 2. It doesn't accept floating point values. Actually, 2.4 is not acceptable here, but they are acceptable for E and F. the floating point types. Okay, so that's it for them. I think I have covered all of these. Also, I have one more thing to talk about. It is the ASCII table. What's an ASCII table? An ASCII table, it is a special notation for displaying characters on the screen. Actually, the keyboard the keyboard encodings. Actually, for example, when I took a look here at our yes, they are A, B, C, D, E, F, G, H. That column actually, the last one here. Okay, here. Okay, you see, this is the representation for them, some numbers. Okay, in hexadecimal and in octal format, and also in decimal. I have the interest in these actually. Okay, so A is represented by 97, B is represented by 98, C is represented by 99, D is represented by 100, and so on. So in C language or C++, when you are going to use character variables like this, okay, you can store what you are going to store within. You could write something like A equals 9 and use it as its value. It's 9 now. Okay, and also you could write some characters within like A, and it is replaced by 97, which is here. Its representation here, 97. A is 97. So these both are the same. Okay, I'm going to show you an example for this. Actually, the cout keyword could know about the variable type actually in order to print its format. I'm going to write A تساوي A equals 97. Let's make it A تساوي equals A. Okay. When you are representing a character like A, you are going to use these single quotation marks. Okay, you are going to use these single quotation marks. Here I'm going to write cout A with a new line for me. I'm going also to use a new line here to clarify. This is a new thing actually. Another one for me for formatting. Let's run this. Okay, here A is printed actually. Okay, let's do a little change here. Let A equals 97 as the table says. Run this. Actually it's still A. Okay, it is still A, no change. So I have told you that your characters are going to be represented by some values from the ASCII table. Okay, when I'm going to write something like 9 and I'm going to printed. Actually, something is not readable on the screen. Let's try something else, like I think one. Okay. This is strange character here. Strange character, very strange character. I don't know what is this, but according to the table, it is called start of header. One is a start of header right here. Okay, one is a start of header. This is the character start of header here. Okay, you see. So be careful when you are dealing with character variables, when you are going to print them on the screen, and also be careful that they are represented with the ASCII table, and also be careful, okay, that it's not a problem for the C or C++ language when you are going to use some special value which is not a well-known character for you. Okay, you could use variables like car anywhere. Actually, it's not only for printing on the screen. That's the thing I would like to say. Let's just here. Okay, I think I have finished my explanation for today. Anyone have a question or something? Go on and raise your hand. Okay, Omar, go on.
About the difference between unsigned and unsigned characters, is it about their binary representation or what? Or we can say both accept all characters alphabets, right?
Yes, when you are going to look at this ASCII table, actually, okay, you are going to see that the biggest one here, the biggest value of the biggest value in the ASCII table actually is 127. Okay, 127 is also sorry, 127 is also the biggest value that could that could assigned character could hold. So there is no problem here. Okay, I have answered your question.
Okay. No. Okay. I can. I see. So, sorry. I wanted to say that the difference between them is about just signed and unsigned. That's all. Or don't know. I want more explanation about the difference between them.
Okay, you want an explanation about the difference between signed and unsigned variables?
Unsigned characters. I.
Okay, so it's no big difference actually. I think something like when we are going here to have let's make some loop or something. Okay, actually let's make a variable here, signed character, say n. Okay, n here or something, and let it equal to -5 or something, and now we have while n is smaller than 6 or something, see out let it be printf. It's better here. Okay, Okay. Okay. Actually, then we have n equals n plus 1. Okay, let's run it, and that's it. What's your question? It prints from -5 until it reaches 5. So there is no difference actually when you are using a character or a non-character variable as a number, as you are using it as a number actually. But let me introduce you to something else. Let it be like this. Okay. Okay, that's n with backslash n. Let's run this. Okay, you see how C
Yeah,
out
I
you
know
see
this.
how C out is going to deal with n, and printf with the formatting of decimal is going to deal with n. Okay.
Yeah, yeah.
Okay, what else?
I think that's all, but just got weird from there's assigned character and unsigned character. But I know that with respect to floating variables, I think it's about what is called IEEE notation about the representation of decimal points
Yes, it's
that
IEEE
has no.
representation of floating numbers. Yes.
I think sign of it has some conditions or just presupposition about its representation.
Look, when you are dealing with, actually this is kind of machine work. It's not your work actually. You are not obligated to think about it, but the machine decodes when it comes to integer types. Actually, when it comes to integer types, to integer okay types, the unsigned representation is called twos complement of the signed number, which is when I'm going to say that I want to have something like -1. Okay, so what's going to be -1? Okay, -1 is going to be like you have let's take all of this. Okay, I don't know what's going on, but okay, I want to represent -1 here. Okay, so you are going to make something like this. You are going to write 1 actually. You are going to write 1 like this. You are going to write 1 actually, 1 here. Okay, so now you have 1. This is 1. Okay, then you are going to make the complement, or you are going to obtain the complement of this value. Actually, this value are going to obtain its complement, which is 0, 1 1 1 1 1 1 and 1. Okay, so that's it, the complement. Okay, now we are going to add 1. Okay, which is going to be like this. Okay, so now we have -1. Actually, this is -1. Okay, how it's going to be calculated? Actually, it's going to be here minus 100 and 108 minus all of these. Okay, these are in positive, so you get -1. Actually, this is called 2's complement. Actually, okay, when you are going to have something like -2, it is the same way. You are going to make all of these zeros, and you are going to write here. You are going to write sorry, here you are going to write 1, that's 2 in binary, and then you are going to you are going to get its complement, which is 1 0 1 1 1 and 1. Then you are going to add 1 here, plus 1, so it's going to be 0 1, and that's it. Okay, this is -2, and so on. This is called 2's complement. Actually, this is for integer types. For floating point types, okay, I couldn't remember the exact way of representation, but it's called IEEE. I think IEEE
IEEE notation.
754, I think, representation. Yes, that's it. 754. Okay, 754 floating point representation. So we are going to search about it, and it's going to represent actually the floating point numbers. Okay, with sign and which are signed and unsigned actually. Okay, there's a mantissa and exponent. Okay, mantissa, exponent, and sign. That's it. Okay, so you have 32 bits, which are 4 bytes here at this case, 4 bytes here. Okay, and they are going to be represented as the first 23 bits are going to be the mantissa, and the next 8 bits are going to be the exponent part, and there is 1 bit also for the sign part, actually, it's to be signed or unsigned. That's it. I have answered your question.
Yes.
Okay,
Yes, thank you much.
you are welcome. You are welcome. Any questions else? Any other questions, guys? Okay, that's it for today actually. Okay, I'm going to send you some emails to decide what we are going to do within the next sessions. So please follow your email inbox and spam junk folders to decide what you are going to do within the next sessions. Okay, I think we are going to meet the next week. So thank you so much. Goodbye.